Bismillahirrahmanirrahim. Okay, next we discuss regarding the example 4.1 here. This example taken from the Chapman book. So we shall discuss the example. So please take your pen and pencil so we can do it together. So once we have the example or the question, so it is preferable that we draw in terms of their circuit. We have here the direction to draw the per phase equivalent circuit of generator to show the parameter of both armature and value of the vice. But even though if you not be requested to do so, please, for my suggestion that you draw the circuit. Because why? Because sooner or later you have to imagine the circuit. So it's better if you can draw, so you can refer to the circuit itself. You don't have to imagine inside your brain how the circuit or where the parameter should be at. So you can draw on the paper and you can refer directly on what is where in terms of the armature, resistance, the synchronous reactance, field, circuit, voltage, the field current, the load current, so where the parameter placed at. And you should write down all the available parameters on the circuit itself such that you can refer directly. Okay. Then next step is that we shall transfer all the statement here into circuit. We have here one statement, two statement, and three statement here. So we transfer all the statement to circuit. So V terminal at open circuit, rated current of rated field volt current of IF here. So V open circuit. So we do open circuit test. So open circuit test, how actually the circuit will be looks like. So this open circuit, we have here EA, we have here V terminal at open circuit. So at open circuit there will be no current that flow through load. Open circuit is open circuit. So IL equal to 0. V terminal open circuit should be at the power or at the same value of EA. EA open circuit equal to 540 volt as stated over here. Then we perform a short circuit. There's no open circuit. Short circuit test. Draw again. When we perform a short circuit test, so what happens is that the circuit will be shorted both together, and we put ammeter in between to measure the current. So right now I load become very high because we shorting the circuit. So in the short circuit current scenario, as I load SC is equal to 300 ampere. 300 ampere. 300 ampere. Okay. Then 300 ampere. So both conditions that will happen or will be performed under rotation of rated rotation of the shaft. That both testing is conducted when the shaft connected to the rated rotation of the machine. Okay, then we perform another test of the DC voltage that we induce into the circuit, armature circuit. So we are performing DC test. We put a DC source into the system, positive and negative here in the system. So we are measuring we have here 10 volt. We are measuring how much the current that flows into the circuit. So it was 25 ampere. 25 ampere goes into the circuit. So this one happened or done without rotation. So rotation is not 0. No rotation being applied. So we just put a DC circuit test to the system. So we are getting this values. So better if you all can transfer, if it even not being requested here. So transfer all the data into circuit, to the circuit. So this is recommended. Okay. Okay. Then it was the question that the circuit now or the motor system are Y connected. We have Y connection and we have delta connection. Y connection and delta connection of motor. So the first scenario is that if the motor in terms of their terminal connected in Y, the DC test performed to the Y connected motors. So you draw how the connection of this test being done. So the incoming DC test here, you will go into the Y connection of motor construction or generator construction. So we have DC test, we perform DC test. We can see that out of 10 volt we put into the system, so 25 ampere are measured. So 25 ampere measured are conducting through 2 channels or 2 branch of RA, armature system. So from the equation of V equal to IR, so we can obtain the R which is equal to V over I. So the resistance now is 2R because we have in Y connection kind of construction. So the current will go to RA channel 1 and RA of channel 2. So we have 3 phase here. So 2 phase, the current will go to the 2 phase. So the same ampere will go to RA channel 1 and RA channel 2 back to the source. So 2RA equal to VDC that we apply divided by IDC that we measure. So it becomes 10 divided by 25 times 2. So we shall get 0.20 ohms. So here should be times 2. So this is our RA. So 0.20 ohm. So we measure or the value of each RA is equal to 0.20 ohm. So we are able to find the armature reactance, armature resistance. Then we need to find the approximate synchronous reactance XS and also the synchronous impedance of ZS. So this is the 3 parameters that we need to find out. Out of these 2 connection of construction of Y or delta connected construction of motor or machines. So RA, we need to find RA, XS, and also the ZS. Okay, so now we try to find out the XS and ZS. So for the ZS, we are talking about Y connection now. So the ZS is the amount of armature resistance plus our synchronous reactance squared and Z. So that's the total impedance, internal impedance of the ZS. And at the same time, this equation is equal to, or the ZS equal to internal generated voltage divided by armature current that flows through the circuit. So EA divide by the I, how much here, or IL here. So Z impedance equal to how much the voltage across the generated voltage here, divided by the amount of current that flows through the skirt, the whole skirt. So the total impedance. But at rated RF that we measured just now, rated RF here, rated RF that comes to the, we adjust such that RF adjusted, increase accordingly until it reaches rated values of 5 ampere just now. So we found that the V phase at open circuit, V phase open circuit, we test the open circuit test, we get 500 photovolt. And this 500 photovolt we have to divide by certainly, because we are looking at, or we try to find the phase voltage instead of the terminal voltage. We are measuring the terminal voltage, but we are trying to find the phase voltage. So the phase voltage here is equal to V terminal that we measured across the two terminal here, divided by cert3. So divide by cert3. So we get the voltage terminal of the phase instead of the voltage terminal across line to line. So we go back to the equation. So the amount should be 311.8 volt. Should be lower compared to the terminal voltage that we measured 540 volts now. Then the I armature that we measured during our short circuit test. So short circuit test, we test this now. Open circuit we measured 540 volt. Short circuit we measured at 300 ampere. So in Y connection, the 300 ampere of IL is the same of current that flows through the phase. Load current and phase current are the same. We have here load current and the phase current. The incoming load current and the phase current are the same. So maintain as 300 ampere. So we have our ZS of RA plus 0.2 squared plus XS squared cert equal to 311.8 divided by 300. So we transfer again the equation here. We put the numbers inside the values, numbers inside the equation. So we shall get, we solve for XS 0.2, so it becomes 0.4 plus XS squared equal to 1.08. Then we solve for XS, we get 1.04 ohm. 1.04. So XS is 1.02 ohm. It's now XS squared. So this is the value of synchronous reactance of our system, 1.02. Okay. And actually the synchronous impedance, the sum we calculate, the ZS is 311.8 divided by 300. We shall get just now 1.04 ohm. So we have done for ZS, XS, RA, and our S, XS. So the three elements already calculated. So we can put all the elements or all the parameters back into our main circuit that we draw just now. So we have to calculate here RA, XS, and also ZS. So done for all the parameters that involved inside our calculation or inside our system. And we can write down here all the parameters here, 0.02, 1.02, and all the parameters here should be written out. Okay. Okay.